Hello, this is Mr. Martin, and today we're going to be talking about the area between two curves. So, with that, we'll get started, and this is why calculus is so powerful. Consider the two functions. You have f of x equals 2x minus 2x minus x squared, and g of x equals x squared. The graphs of these functions are shown on this page. So here we have, let me write with my ballpoint pen here. Here we have the graph f of x equals 2x minus x squared. And of course, this is g of x, which equals x squared, the one. And so our objective right now is to find the area between the curve. The area is in here. Now, of course, this is why it's a curved area, so it's more difficult. But as I look at this, I'm going to say, how am I going to possibly find that? Well, we're going to use the principles of the integral to solve this. So as I look at this particular plan, if I can take this, notice I have a rectangle here. If I can break this into a whole bunch of little rectangles, I know how to find the area of a rectangle. It's just the height times the width. And in this case, the height of this rectangle that I've drawn here, and I've drawn it a little bit off, is the difference between f of x minus g of x, isn't it? It's the point here on the graph, which is f of x, minus the point here will always give me the height of my rectangle. And the difference, delta x, which is our small change in x, we're going to represent by dx. So with that, we can go ahead and write an integral. Now the thing that we need to know is how far are we going to go? And it looks to me we're going to go from the intersection where they intersect on the bottom to the intersection on the top. Now because I've drawn an accurate graph, it appears that the x value, my x is going to go from 0 to 1. But let's just make sure. Let's draw out our functions. I have x squared is my g of x function. If I set that equal to 2x minus x squared, that's going to give me the solutions where those two particular functions intersect. And of course, by doing some basic algebra, I get 0 equals 2x minus 2x squared. And factoring a 2x out of each term, I get 0 equals 2x times x, 1 minus x. So I can easily see that my values of x from there are going to be x equals 0 and x equals 1. So let's go on to our next page and write out a formula. So if I take the integral from 0 to 1, that's the region that we're going to, of f of x, which was my top function, minus g of x, all multiplied by dx, which is my area. If I sum up all of those rectangles, I should get the area. So let's go ahead and do that. Substituting in for f of x, since we know that f of x is 2x minus x squared, minus g of x, which is minus my x squared, all multiplied by dx. I can combine these terms, and I'm actually going to split the integration now into two different integrals. 0 to 1 of 2x dx minus x squared is 2x squared, isn't it? So I'm going to take the integral of that, 0 to 1 dx, and I have two integrations. Now these are easy ones, and they've come out nice for us. So let's go ahead and take a look at that. What will that come out to? It's going to be 2x squared over 2 evaluated between 0 and 1 minus 2x cubed over 3 also evaluated between 0 and 1. And of course the 0 portion on the bottom of the integration, when I plug in 0, it's going to be just 0. So this actually, the whole thing is going to equal, when I plug in 1 for x squared, it's going to be 2 over 2, which is just 1. And on the second half, it's going to be minus, when I plug in 1 for x cubed, it's 1, so it's 2/3. 1 minus 2/3. So our solution in this case is 1/3. So what are we saying when we have a 1/3 solution? What we're saying is that the area, again, that's bounded by these two curves is 1/3. And again, the top curve was represented there, and that graph is 2x minus x squared. The bottom region, or the bottom bound on the graph, is the graph x squared. I hope this helps, and if we will go on for more videos later on areas between two curves.